Hello everyone. Today we are going to talk about how I make my own cubeSat, and you guys don't have to follow all of this, but at least you guys should have a concept of how to make the cubeSat using Raspberry Pi. Let's get started. So there's some picture of the cubeSat, different view of it, and this is the 3D print of the structure. We'll probably release this structure for you so you can print it out. And please prepare some standoff. This is called standoff, and screw and nuts. All you need to do is, or maybe 8 screw and standoff like this. So put it like this. So this part is like in the middle, and this is the outside structure. So put it like this. The standoff, in this picture I use 10 mm, but I guess you can use 8 mm instead, because as you see there's a gap in here, so you can strengthen it, because if your cube the standoff is too long and the whole thing will shift up and you cannot close the lid. So I guess 0.8 is okay, or 1 mm is 10 mm is okay too. So this height. And then there's another view. So and now I guess most of you knows about the Raspberry Pi. So this is a Raspberry Pi, and this is the battery circuit. So you don't need to use this, but this is what I use because it can put underneath, under the Raspberry Pi. So some of them is put it like on top of it, then the whole thing will have to stack up higher and higher. But well, there's different way to get it done. And this is the battery. And remember, the polarity is important, so do not mess up the polarity. This is positive side. And this is the heatsink, and it's good to put the heatsink. Now it's winter, that's autumn is okay, but I tried in summer. I put it outdoors. If you don't have a heatsink, or even you don't have the fan, it will get hot easy, and the Raspberry Pi won't run that smoothly. So that's why the heatsink is good to be used. And so you put the battery there, so the polarity is important, and then you put the Raspberry Pi on top. Now we talk about the camera. So to install the camera, lift up this black piece and then push the wires in. The blue color side is close to the USB, because it's easy to mess up. I messed up one time, so remember to have orientation like this. And if you look at this slot, this is the slot you're supposed to slide the camera cable through it and then connect it. If not, then you have to take it out and then stick it. You will know if you didn't follow the procedure. So this cable should go through this slot and then connect it to this plug. So there's a different view. And then when you put the battery pack underneath, for mine is like put underneath, remember this couple push pin, or the alignment is very important. So be careful of the alignment, and you have to stuck to the bottom of this metal piece. So the power is go from this push pin all the way to the board. And for the screw, please unscrew it until you don't see that something stick out, and then you push the heatsink on top, and then you screw it back. So yeah, do it for all 4 screw. And then so this is the products, and then we are going to put the expansion port on top. First we put the expansion 40 pins expansion things underneath, and then push the extensions to the 40 pins on the Raspberry Pi, and then this sensor board. And the other side you should have the stand off, so put the two stand off there, so it's kind of less stable in a way. You can put the blue tag there too, but it's not necessary at this moment. And this is another view. And then now we're going to connect the sensor. When you get the sensor board, sometimes the pin is not soldered, so I guess you guys have to do the soldering or ask your teacher to help you to do solder. And prepare all these female to females 10 cm connection wires. You need a lot of them because just to be sure the color scheme is correct, because if you look at these rainbow colors, you only have 1, 2, 3, 4. If you look at the red color, 1, 2, 3, 4, 5, 6, 7, 8. So yeah, we need a lot of rainbow wires. So connect this is the photo sensor or photo diode. There's a close-up. So V is the power. The power is always positive, so always positive and should be red. And the ground, the G is ground, and it's always dark color, black color or brown color in this case. And then S is a signal, so any color is fine. Why the color scheme is important? For example, after you put the whole things together, there will be like 30 or 40 wires, and it's hard to do the debugging, and especially you don't want to burn the board. So the most important wire is the positive and negative. So if something's smelled, is burned, or something's not on, so the first things we look at is the power. So that's why the red and black is a color scheme that people use. So if something's wrong, they will turn off the board immediately and just look at the red and black color or brown colors wires. And then if these colors wires okay, then they will look into the signal wires. You will know later if you do more debugging and say, okay, the whole system doesn't work. There's too many wires, I don't want to look at it. Then you understand why the color scheme is important. So this different view of it. And then connect the other sides to the analog. This all the analog signals. So A in 0, 1, 2, 3. So connect all this in here. It's different view of it. So this is what it looks like for the temperature sensors. So in here I use the analog signal. So that's why we need this analog board to get all this data. If you have different kind of sensor, then you may put it in different slot. Okay, so this is the GPS modules. Oh, let me explain. I forgot to explain it here. So this is the gyro, the accelerometers, and the compass. So this is the MPU2 and MPU 9250, and these four are the light sensor. And this is the one TEMT6000, and yeah, you can get in Taobao or AliExpress and stuff. So these are the photo sensors, and this is a GPS modules, and this is a GPS antenna. And I guess we're going to give you the link of where to buy all this. And so this is the GPS modules. Follow the color scheme. So VCC is power, this is ground, and then RxTX. This is the UART connection. This is a better view of it. So the ground is like brown color, the power is 3.3 volt, and then the RX is actually to the TX, and TX to RX. This is the UART protocol. When you have a TX, you go to RX, RX to TX. So you will see the color swaps. This TX is yellow, and then yellow. This is RX. This is a UART communication, and this is the main sensor board. So VCC, ground, SCL, SDA. So this is the color scheme, and then connected to this four. This is the I2C communication. If you see SCL and SDA, then this is I2C, and this is power, and this is ground. And then this is the antenna. So gently push the antenna's connector to the board. You can hear a click sound. And then this is the overall system. And this is sticky tape. This is very useful, not just in this project. Later on, if you do or your own project, yeah, you will see it's really sticky and it's so easy to use. But remember, do not put too many of these to for example in this project, because if you have too many, right, somehow you want to take it away, take it apart, and it takes maybe a minute just to pull it slowly. And yeah, so I just put 4 small tape here. And for sure, if you have time, you can make your own like screw hole and try to screw it in and stuff to have more secure frame. And then stick the whole set on top of this 3D print structure. And then for the GPS modules and the antenna, do the same things. And then stick it in this side. And then the antenna to the bottom. And then now we're going to put the rest of the 3D print to the cubeSat. And for the camera, I found it is easier just to use a blue tack, put it in these 4 holes. Yeah, for sure later on you can use a screw, but it's hard to explain, like maybe you put the camera in this side or that side, or orientation does not work. So easy just to use the blue tack, and later on if everything is confirmed, then you can use a screw. The screw, I guess, is like M2 or M2.5, I forgot. So it is not easy to find this kind of small screw. So yeah, and then put it yeah, to this side. Yeah, so it's hard to explain this. Yeah, this is a correct orientation of it. The wire is like on your left side, and then there's different view of it. And then put the main sensor board somewhere. So I stick it like in here. So this is how it looked like. And now we're going to close the lid, and then push the 4 photodiode sensors like this, and then screw it in. And then now is the 32 gig SD card, and I've heard you guys know about the know about how to burn the image to the SD card. If you don't know that, maybe you can try this etcher or different kind of SD card burner. And this is what I use. And if you don't know that, so search for this name in the YouTube, and you probably get the idea how to flash or burn the SD card. And we probably give you the image. So after you have an image, burn it to the SD card, and then put it in the Raspberry Pi. and then now you can plug it in the power board. So this is the power board, right? And this is a slot USB-C, and then plug in the HDMI. Remember, the Raspberry Pi uses a small HDMI connector. And then it's not that clear, but for the power board, there's a button at the side. So you hold it for maybe 2-3 seconds, and the board will light up. It's a blue color. On top is blue color. May not be easy to see it, but I guess the pictures, the pictures better view. So yeah, so it means that it power up. So later on, if you want to shut it down, first you shut down the software in the user interface, and then you push this button, hold it for 2 or 3 seconds until the blue LED turn off, then it is off. And after it turns on, the Raspberry Pi desktop comes up, and then click the web browser, and then click this white icon, and it's actually go to your local host. The port is 1880, and then UI, and then there's something else, and that's it. So this is the UI, and this is the look of different color of the cubeSat, and this is the user interface. So that's it. So this is just a video to tell you how I make my own cubeSat. You guys don't need to follow my cubeSat. You guys should develop your own. But for starting, maybe you can try to make this first and then modify here and there. So yeah, so that's it. So thank you. Bye bye.